The topic today is maximizing biochar value through waste heat recovery. I am Natalie Van Dyke. I'm the Sales Director for Renewable Energy and Sustainability Strategies with ElectraTherm Incorporated. We are located in Flowery Branch, Georgia, outside of Atlanta. Okay. The premise for my discussion today is the addition of high-tech waste heat utilization within pyrolysis system design is beneficial to future-proofing the value of biochar operations, seeking to maximize both long-term benefits of carbon credits as well as short-term CapEx advantages. Okay. Pyrolysis. Everyone here knows pyrolysis. The reason we're talking about this is most pyrolysis operations operate within an envelope of 300 to 700 degrees Celsius. In many cases, it can even be higher than that. But this represents a significant opportunity to extend biochar profitability through the addition of waste heat recovery power generation, okay, to your pyrolysis operation system designs. We have several goals for this presentation. I will quickly and briefly introduce ElectraTherm just so you know who we are. I will explain Organic Rankine Cycle at an incredibly high level, not low level. If you want deep technology on it or information, please stop by our booth. We will examine the profitability of waste heat recovery as a system design addition, and also illustrate how ORC power generation can coexist with and often enhance your existing biochar production system processes. Okay. First off, we are the global leader in low temperature organic Rankine cycle. That's who ElectraTherm is. Okay, that advanced, I apologize. Okay, we currently have 200 ORC units, actually more than that in the fleet worldwide, representing over 100 installations in 14 countries. We have 2.5 million operating hours in that fleet and counting. You can see the flags across the bottom. Those are some of the countries that we exist in. We are a small company owned by a large company. ElectraTherm is a US company, but we are owned by a German conglomerate. This is advancing on me. A German conglomerate called the Bitzer Group, which is the largest privately held manufacturer of refrigeration and air conditioning compressors in the world. They have about €1 billion annually as their throughput. And the reason they own us is because the heart of the ORC is in fact a screw expander, okay? An expander is a compressor which is run backwards, and the Bitzer Group produces 20 to 30,000 of these annually and has for dozens and dozens of years. The core of our technology is something that has been in continual utilization for a very long time, and it's been shown to be very, very rugged. Additionally, we do have support in over 60 countries, which gives us a very wide scope of the ability to support these things. Okay, Organic Rankine Cycle. What have we got? Why is this doing this? I apologize. At its heart, Organic Rankine Cycle is in fact an appliance, okay? It takes advantage of the differential between high pressure and low pressure on heat. Hot will go to cold, always. That creates a pressure differential. That will internally boil a refrigerant, which is the organic working fluid, and under pressure, the vapor is fed to the twin screw expander, which will spin an electric generator that is housed within that expander, and that creates the mechanical work to produce energy. The vapor is then recooled on a cold side. We have cold water on the other side, you can see. And when it is recooled, it is condensed, and then the refrigerant is pumped to the high pressure side, warmed by hot water again, and it goes over and over. Very simple. It is an HVAC loop in reverse. This is our product line. I don't put this up here as an endorsement. I do it, excuse me. This is really, did not do this at all online. Okay. This is representative of the sizes that ORCs come in, very much across multiple manufacturers, but these are sizes that work very well in the pyrolysis space, as we've seen those sizes through most manufacturers. These are ours. We have a 75 kilowatt, a 150 kilowatt, and we are currently in production or in prototyping for a 300 kilowatt. We also have what's called an active cooler, which can produce 75 kilowatts of energy while producing, also supplying 800 kilowatts of thermal cooling, which is very interesting because most of your pyrolysis operations will in fact require cooling. Again, mostly this is here so you understand these are the sizes that are very representative for this business space. We are not the only ones who make these, but we're happy to talk about them, and I'm sure other people are as well. Okay. We operate in a facility from 150 degrees to 300 degrees Fahrenheit is our ideal temperature range. Others may have a different range, but that is very much a space, gracious me, I apologize. That is very much a space present in pyrolysis equipment. You will see, however, you also have other things that may be attractive or, I am so sorry, identifiable in this space. You see also biomass, biogas, and combined heat and power. These are things that you may also see in some of your agricultural applications. The biggest thing to know, though, is we are heat agnostic, and we work in all of these spaces very reliably. And we can work very reliably in yours as well, in pyrolysis. Now then, regarding your applications, you can see here, these are revenue streams you're probably very familiar with. You have the biochar production offers opportunities to monetize multiple streams. Carbon sequestration, waste management, soil improvement, these are all probably very much in your wheelhouse. But there's a fourth, and it is energy production. And by a show of hands, I would be interested to see who here is currently utilizing energy production in their pyrolysis applications or in their current system design. 2, 3, okay. And design as well, okay. Very good, okay. Still, small percentage. There's a lot of opportunity here. You're leaving 25% of your opportunity on the table currently. All right. Why add it? Let's talk about it. Besides the 25%, here's where the 25% comes from. We're going to future-proof your pyrolysis operation for biochar certification. If you look at this, what you see here is a copy, this is the front of the EBC, okay? The European Biochar Certification Manual, okay? The key profitability regarding this hinges on creating high-quality, high-technology biochar. Okay, if you neglect waste heat energy production in your design, you are missing something that is very, very integral to this certification. Let's look at this. The EBC was established in 2012, so that's, it's a dozen years ago, not terribly long ago. In that dozen years, it's had 10.3 revisions, okay? It has been rewritten and rewritten. The guidelines, there have been 2 revisions in the past 12 months. Okay? The EBC guidelines specifically mention energy efficiency. Okay? If you go to Section 8, many of you are probably very familiar with this. Okay? Specifically deals with pyrolysis, states must be operated in an energy efficient manner. Okay? The use of renewable energy resources or surplus electricity is recommended. If you go on to Section 8.4 regarding biochar production, specifically, it states excess heat must be used to at least 70%. Okay? How many people are using their excess heat currently? In some portion, in some manner. Not drying anything. How many of it's in your design? Okay. Solid percentage. If you look at future-proofing pyrolysis operations for biochar, when a key profitability goal hinges on creating high-quality and high-technology biochar, don't neglect waste heat energy, okay? You have a revision of 10.3 times for this document. It says 70% heat today, but it also says high-tech. Okay, Vera specifically says high tech. It needs to be utilized in a way beyond high efficiency. If you look, and granted, this is a European certification, and I can hear some of you saying, we're not in Europe, Natalie. Why are we talking about this? I don't understand. Why are we talking about it? These are the certifications we use in the US. Every one of these standards chases the EBC. The EBC is the Bible by which these follow. And when the EBC moves, so do these. Okay? Additionally, all of these standards are competing against one another. They want to be the certification that is considered the greenest, most trustworthy, most reliable, and of the best pedigree. How are they going to do that? How are they going to get that certification? They are going to continue to push one another in terms of what that means. And how are they going to do it? They're going to do it by being more efficient and use better utilization of the waste heat. Better is considered higher tech. So that the utilization you're using today do not guarantee that by revision 12 or revision 10.7 that the one you're using today is still going to be in space or be valid. If you want to meet these certifications, you need to be looking at where it's going, not where it is. Additionally, okay, if you look here, biochar and certified carbon credits with higher energy efficiencies are likely to be in higher demand by consumers and command a greater price in carbon markets. Consider that. Even if the certification doesn't change, these are metrics that all of those certifying bodies are absolutely going to be quantifying and tracking and reporting to their consumers. Their consumers are Google, Microsoft, Meta, Chevron, Volkswagen, Shell. These are the people that are making long-term contracts for carbon credits. Your facility, they're going to call up and say, I need 5 years of everything you can give me. Tell me how you're using your energy. If you say, well, I'm drying, the person on the right of you says, well, I'm creating energy at drying. That's a higher tech utilization. He gets the contract for 5 years, okay? This is how you need to be thinking about this. This is a strategic advantage to you. Additionally, what you're doing when you do this, you're actually reducing your carbon intensity, or CI score. That CI score, carbon intensity, is used in the fuel markets. Most of you are probably more familiar with the term LCA, okay? That's what you're looking at. It's very similar, very, very similar. But this is the market trend that we are basing these projections on, and I promise you will want to follow what we're about to say, okay? CI score has been predictive of commodity value increase in the renewable natural gas markets. May I have that water there, please? I'm sorry. I'm going to take a quick drink, pardon me. Thank you. Thank you very much. Okay. Okay. Oh, let me go back 1 second. What happens is carbon intensity is the amount of carbon that is utilized to create your biochar, okay? There will be a score attached to it. If you are using the energy, the waste heat from your system to create energy, and that displaces energy from the grid, that is considered zero emissions utilization. It's the same as if you're using wind energy or solar energy, and it reduces your carbon intensity score. That carbon intensity score, same as LCA, as it comes down, as that score goes down, the value of your commodity goes up. And that includes your credits and likely your biochar as well. Okay, so it's going to affect 2 of your markets that you're monetizing. Now then, additionally, what you want to consider is opportunity cost associated with this. If you are integrating waste heat right now, waste heat is having a glorious moment and is attached to the tax credit advantages from the Inflation Reduction Act, okay? Waste heat projects currently are eligible for funding cost offsets through the Inflation Reduction Act, as well as the income tax credit and the production tax credit. Credits range from 30 to 50% of project costs based on eligibility factors. Okay, the eligibility factors include, and I will state them, 30% is just by putting waste heat energy on your project. You get a 30% tax credit. And that 30% tax credit is going to afford a halo effect on the project. You see the word listed here is project cost. It is not ORC cost, it is project cost. The project is your pyrolysis machine for the biochar production. It is the waste heat recovery. It is the loop attached to bring it together, okay? It is going to afford a halo effect across the entire project by integrating waste heat. If you don't integrate waste heat, you're not going to get it. Now, here's my caveat. I nor anyone at ElectraTherm are a tax accountant, okay? All of this needs to be vetted through your own tax people, and in fairness, some of the guidances and rules on these are not finalized through Treasury, okay? There is a lot of horse trading going in Congress still. Thank you very much. But they're getting there, and it's very serious. You get 30% just for adding waste heat recovery. You can get an additional 10% for having Buy America content on your project. So whoever you're speaking with regard to your manufacturing and your sourcing, talk to them, have that conversation with them. We believe ourselves to be compliant with the rules as they're stated today. Okay, I definitely check with other providers. And the final 10% that you can get up to 50% tax credit is related to whether or not you are in a geographically impacted community, whether that be through energy economy impact or like a brownfield site, okay? Most of Texas, Oklahoma, West Virginia, and any place that ever had a coal mine or a coal burner is probably on the list for that last 10%, okay? Additionally, there are direct pay options. If you don't pay taxes, you can sell your tax credit. Money's on the dollar. Definitely check with your tax people on that one. That one's kind of black magic. Oops. Excuse me. Okay. We have done applications many times harder than this. This is not going to affect your operations. If we can keep a steel plant up and other things, your pyrolysis is going to be just fine. Okay, we can talk to you about pressure drops, any threats you have. We have engineers at our booth, more than happy to talk to you about this, but we can be mission critical on this without expanding or affecting your issues. Okay, and here's another information on that. Whatever additional things you're doing, if you are using drying, if you're doing feedstock, if you're doing engine cooling, whatever else you're doing, we are not going to affect that. We can work very symbiotically with it in most instances, okay? And in this instance, you can see, should it be required, if you need a return temperature for your dryer, we can provide a guaranteed return temperature. Others probably can too. I check with them, okay? I want to be very clear about this in terms of what we're talking about. But it's very likely, definitely we can do it, okay? If you have an existing use for the heat, but you still want to future-proof, talk to us. We can work together, and we can still make it happen. Okay, finally, in conclusion, okay, the 5 takeaways I think would be important for you to know is, number 1, certification requirements for biochar credits is a moving target, okay? Future-proofing is key. Do not forget waste heat utilization as you're making your process designs. It could be a very expensive omission. Number 2, the heat utilization you are pursuing today may meet the 70% usage threshold, but it may not be sufficient for credit certification in the future, okay? Consider that as you're going forward. There are going to be very, very aggressive green initiatives in these people that are buying these consumer credits. That's their goal. They are going to buy high pedigree, be high pedigree. The carbon intensity score will likely be a key market driver. Plan now to meet that challenge because your competition's gonna. If you're not doing it, the guy next to you will. He'll get the sale. Funding availability under the Inflation Reduction Act right now can greatly assist with your CapEx. Talk to your tax pros. Consider that in your modeling. 50% off your CapEx. Looks pretty attractive, but it's time limited, so talk to your tax pros. And finally, deployment of an organic Rankine cycle technology for these strategic financial reasons is not going to interfere with your manufacturing, your major mission. You're still going to be able to do everything you want to do, and you're going to be able to do it effectively without impact on making high-quality biochar. How'd I do? Excellent.
Biochar.org appreciates the support of our sponsors, exhibitors, presenters, and attendees. We look forward to seeing you at our next conference in September 2025.